Welcome to Lesson 3. In this lesson, you'll create your very first virtual reality model, a Hello World VR model using a library called A-Frame. Start by navigating to this URL, alvin/vr101/hello world. This will open a new project in Glitch. You should see a screen like my right half of the screen, some files, some code, and a header that is cut off my recording. Then, I suggest placing your Glitch and Skillshare windows side by side as shown here. I'm going to minimize my file browser by clicking on the arrow that's pointing to the left so that you can see more of my code at once. You don't have to do this. To explain the code that you're looking at an HTML web page. HTML is made up of a bunch of tags, like the one shown on the left. Tags have a start tag and an end tag as shown here. End tags are denoted using the /. If you're already a web dev pro, you can skip over the first minute or so where we talk about HTML. This is your Hello World HTML code. Notice the entire document is wrapped with an HTML tag. Here's the start tag and here is the end tag. Inside of the HTML tag, there are a pair of head and body tags. These three tags, HTML, head, and body, more or less define the starting point of any HTML document. Inside the head tag, we add invisible properties of the web page. In this case, we've added a title for the web page. And we've also added a line that allows us to create virtual reality experiences using A-Frame. Inside the body, we add the virtual reality scene using A-Scene. I've added two lights for you. We'll talk about lights in more detail later. Back to the slides. Throughout this class, you'll create objects in this virtual world using HTML. The simplest of objects are called primitives. Primitives are basic 3D shapes like cubes, cones, and spheres. In A-Frame, you create a primitive by using an HTML tag. As we said before, tags in HTML have a start tag and an end tag, as shown here. End tags are denoted using the /. There are several different tags we will use. All tags have the same less than, greater than, and / as denoted in black here. However, each tag will have a different tag name, denoted in orange here. For example, here's the body tag that we saw earlier. And in A-Frame, here's the box tag. This creates a cube in our virtual world. Here are all the parts annotated. Let's try this code now. Go ahead and click right where it says your code here. I'm going to click on the end of line 11, hit enter, and now type in less than A-box greater than. Notice that Glitch autocompletes the end tag after we add a greater than. If you have a typo, for example, let's say I forget the dash, I'll type in A-box. Glitch will create an end tag with your typo. You'll need to fix both the start and the end tags manually. To preview your model, go ahead and click on, in the top left, Show, and then click on Next to the Code. Right now, this preview looks empty. You don't see anything, but that's because we're inside of the box. Go ahead and click into this preview window. Use the arrow keys or WASD to move outside of the box. And here is the box on the ground. You can also drag with your mouse to rotate your camera. Primitives can be customized in a few different ways using components. For example, here's the box we just defined. We can now add the shadow component. This component shadow will allow the box to cast and receive shadows. It does not require a value. Let's try this now. Back inside of your code, go ahead and right before this greater than sign, I'm going to type in shadow. And once again, to preview your model, go ahead and click on the preview window and then use the arrow keys or WASD to move around, and you can see now there is a shadow. We can also change the color of the box. We will do that by setting the color component equal to the blue value. The text colors here are only used for emphasis. The purple text is the component name. The pink text is the component value. Sometimes, I'll add line breaks between properties like this. This is just so that you can see all of my code without me scrolling horizontally. Whether I put all of the code on one line or on multiple lines, the code will behave the same way. Now, let's change the color of your box to blue. So, in your code, on the right-hand side, I'm going to click on this to minimize our preview so that you can see more of my code. Right after that shadow, I'm going to type in color equals blue. Make sure, don't forget your double quotes. Once again, to open the preview, you can go to Show and Next to the Code. However, in this case, I noticed that the preview has already been opened because there is a gray box behind this button, so I can go ahead and click on this button on the right to re-expand my preview. Once I've re-expanded my preview, click into the preview, and I can move around to see my brand new blue box with a shadow. Let's change the position of our box. Position is defined using 3 axes. The x-axis is horizontal, positive x is right, negative x is left. The y-axis is vertical, positive y is up, negative y is down. Finally, the z-axis sticks out of the screen. Positive z is towards you, negative z is away from you. Here are the 3 axes illustrated. To change the position of the box, set the position attribute. The first coordinate is x, the second coordinate is y, and the third coordinate is z. Here, we change the z coordinate to -3. This means we move the box 3 units away from us. Notice the coordinates are denoted without commas, just spaces between each pair of coordinate values. Let's go ahead and try this in code. I'm going to once again minimize my preview window by clicking on the right arrow. In here, I'm going to now type position equals double quote 0, 0, -3. Now if I re-expand my preview, you can see the box without having to move the camera manually. It is especially important to include double quotes around your attribute value, so don't forget those. To complete your knowledge of transformations, we'll also cover rotation. The 3 axes are the same as before. We can rotate along the horizontal or x-axis, the vertical or y-axis, or the z-axis, which points straight out of the screen towards us. To understand which way a positive rotation turns, use your right hand. Curl your right hand into a fist, and with your thumb pointed in the axe's positive direction, the curl of your fingers indicates the direction of positive rotation. Try this now. Curl your right hand into a fist, except with your thumb sticking out. You can verify that the x-axis and z-axis rotating arrows here are correct. Positive z rotation rotates the object left. Positive x rotation rotates the object towards you. To change the rotation of the box, set the rotation attribute. The first coordinate is x, the second coordinate is y, and the third coordinate is z. Here, we change the x-coordinate to 9 degrees. To understand what direction that is, check with the diagram in the top left, and check your curled right hand. Positive x rotation rotates the box towards us. Notice coordinates are denoted without commas, just like before, just spaces between each pair of coordinate values. Don't forget double quotes around your attribute value. Let's try this now. I'm going to minimize the preview and then type in here rotation equals, and I'm going to actually write 900. Go ahead and re-expand your preview, and now you can see that the box is rotated towards us very, very slightly. We can move left if we're not quite convinced. Now, we'll cover 3 tips for keeping your HTML code organized. Tip number 1, add an ID to all tags. I'm going to show you now in the code. Go ahead and minimize your preview, and inside of your code, I'm going to add another attribute here, ID equals player. Since we just have one object, this ID doesn't help too much. However, in later lessons, we'll have many, many objects. At that point, IDs are very helpful for finding objects in our scene. Next, we'll need to explain what a frame of reference is in order to introduce our second tip. First, I'll create another entity. This entity is not actually an object. It's just a way for us to group objects together. Go ahead and type in a-entity ID equals to parent. I'm going to delete the automatically created end tag, and I'm going to paste it right after this tag on the bottom, the original box that we created. Once I've done that, I'm going to select this line 13 with the player, and I'm going to tab. This tag is what we call the parent tag or parent element. We refer to the box as the child tag or child element. Then I will move the parent, not the box, to the right. Change the parent's position to 100. Go ahead and type in position equals 100. If you open up your preview, you'll notice that the box has now moved to the right as well. Go ahead and minimize your preview. I'm now going to move the box up. So here, I'm going to change the y value in the position attribute to 1. And if I open my preview, you can see now that the box has moved up. So what's going on exactly? Let's go ahead and look at this frame of reference. Our parent was moved to the right as shown in the diagram on the top half of the slide, and relative to the parent, our box was moved up as shown in the bottom half of the slide. As a result, we perceive the child box as being in the top right of the screen. This is what is called a frame of reference. This leads us to our second tip, which is to use parent entities to group objects together. This keeps our code more organized. You'll see examples of this in later lessons. Tip number 3 is to indent all children tags. Here's an example. You may have noticed me indenting inadvertently. To some degree, Glitch also does this for you. With proper indentation, you can tell which primitives belong to which objects. That's it for our 3 tips. In the top left, click on Show, and then in a new window. In this new window, you can then access the URL for the web page. You can share this URL with anyone that you'd like to view your VR model. If you'd like, you can now load up your VR experience in your VR headset. If you have a Google Cardboard, load the URL on your phone, click on the virtual reality button in the bottom right, which says VR right here. Then, put the phone in your Google Cardboard. Take a look through the lens. You may have to turn around to find your blue box. The process is similar for an Oculus Quest. Access the Oculus browser and access the URL. The Oculus browser will access the website directly in VR mode. This concludes the lesson. You've learned a lot in this lesson. This is a quick summary of the concepts you've touched on: primitives, components, position, rotation, and frame of reference. You also got 3 tips for clean, organized HTML code. If you'd like to access and download these slides, visit this URL. That's it for your Hello World virtual reality model. In the next lesson, we'll start building a virtual reality version of a scene in nature. Welcome to Lesson 4. In this lesson, we'll start converting a scene in nature into a virtual reality experience. Start by navigating to this URL, alvin/vr101/hello world. This will open a new project in Glitch. You should then see a page like the one on my right, a file browser, a heading that is cut off, and some code. Like before, I suggest placing your Glitch and Skillshare windows side by side as shown here. In these next 3 lessons, we'll make a stylized virtual reality version of a temple. I've pulled photos from a website called pexels.com where you can find high-quality, free-to-use photos. In particular, I've picked one of the first photos of a temple, a Japanese shrine or gate. The takeaway from this lesson is learning how to simplify pictures like this one into basic primitives like boxes and cylinders. There are 4 parts to this lesson. In part 1, I will cover the basic primitives for this temple. Here's the temple again. On the right hand of the screen, I'm going to click on the left arrow to minimize the file browser so that you can see more of my code. Let's go ahead and get started. Start by defining an entity to contain your temple. Note this entity is not actually an object in your VR world. It's just a way for us to group other objects together. Go ahead and click on line 16 in your file. I'm going to add a few extra lines and then type a-entity id equals to temple. Right, so that is the ID of our temple. This spacing right in front here, so I've added a few different tabs. That doesn't actually matter, but just to keep your code clean, I have tabbed it so that it's aligned with the previous lines. Now that I've got the ID, let's go ahead and add the shadow so that your temple can cast and receive shadows. All child objects will inherit the ability to cast and receive shadows. We'll also change the position. I'm going to move the temple up by 1 and back away from the viewer by 3 units. Let's now start by making the left pillar. To stylize this model a little bit, we'll use a cone so that the base of the pillar is wider than the tip of the pillar. Before we begin defining this left pillar, go ahead and click in between your 2 start and end tags. Hit enter to create a new line. I'm going to do that again and then hit tab so that now you can define your child tags within the temple. As always, start by identifying the primitive, the ID of the left pillar. We're going to make a cone and then type in ID equals to pillar dash left. I'm going to add a greater than sign to complete the cone. Now, give it a radius on the bottom of 0.15. I'm going to type in radius dash bottom equals 0.15. You'll notice that I've created a new line here instead of just a space between the 2 components, ID and radius dash bottom. This line break is completely optional. You could keep all of your code on one line if you wanted to. I chose to create a new line for each component so that you don't need to scroll horizontally to see the code for this pillar. Let's next define a top radius of 0.07. Radius dash top equals to 0.07. We'll also give it a height of 2 because the temple's origin is at y is equal to 1. Let's now define height equals to 2. And We move the pillar to the left by 0.65, which means a x-coordinate of negative 0.65. In case you're wondering how I got these oddly specific values like 0.07, I tuned these values beforehand to find the best value. If you're wondering how to pick the best value yourself, I've got a tip. This tip is to use the A-frame inspector. Now, because my screen is already so tiny, I'm going to maximize my glitch window. And here is now my glitch window maximized. To use the A-frame inspector, you'll first have to open the preview. I'm going to click on the top left, Show, next to the code. Now you can see my preview on the right-hand side. You can see the one cone standing up, the left pillar for your temple. Inside of your preview window, click inside of your preview window, then hit Control Option I all at once to launch the inspector. In the inspector, you can then select the object that you want. In my case, I'm going to select the pillar. Then you can change any attribute you want and see its impact visually in real time. In order to see more of this inspector, I'm going to drag this resizable bar right here. So here I'm going to actually change the Y position to be lower or higher. I can also change the rotation along any of the axes that I want. However, you might want to plug in here 30, for example, to see what it looks like rotated along the x-axis by 30 degrees. Important note though, without additional setup, you can't actually save the edits that you make inside of the inspector. For simplicity, you should make as few changes as possible in the inspector. This is just because the export function in the top right here, as of the time of this recording, actually sometimes fails to export your adjusted settings. So in short, use the inspector to see changes quicker, but add your adjusted settings to your HTML manually to be safe. I'm now going to click on Back to the Scene so that I can close the inspector. I'm also going to drag this preview window so it's a little bit smaller, and then I'm going to minimize the preview by clicking on the arrow. Now let's go ahead and copy and paste for the second pillar. Just to be consistent, I'm going to click right after this double quote and hit Enter. And then I'm going to copy and paste this code and paste right below, and then rename this to pillar-right. The right pillar is just to the right of the origin, so we're going to change the x-axis value to positive 0.65. Now I'm going to show you both the picture and the code side by side once more. So here's the temple once more. Next, define the lower of the two bars running horizontally. We're going to define here a-box. We're going to give it an ID, so this is bar-lower. And then we're going to set the width, height, and depth. However, instead of defining the width, height, and depth separately, I'll use the scale attribute. This attribute, as it sounds like, scales the object in each direction. Scale of 1 is equal to width of 1. So the first coordinate is the scale along the x direction, or in other words, the width. We're going to set scale equals to, and the width will be 2. We're going to make it short, so the height will be 0.15. And we're going to make it a little bit wide, so the depth is going to be 0.1. Finally, we're going to give it a position. Let's raise the bar to a height of 0.65. So we're going to type in position equals 0, 0.65, 0, and make sure to add a greater than sign, and that will complete the tag for you. Next, we're going to define the higher of the two bars running horizontally. Start by defining the primitive. So we're going to write a-box, give it an ID, just like always. We're going to now set scale equals to, we're going to give it a width of 2.2, a height of 0.2, and a depth of 0.25. Then raise the bar to a height of 1.05. So position equals 0, 1.050. Okay, so now we've scaled the object so that it has some width, height, and depth, and we've also given it a position where we only change the y coordinate so that the object is higher. Finally, we're going to add a cap, so this top, very, very tippy top portion of the temple. And once again, this is going to be a box, so I'm going to go to the end of line 31 for my file and hit Enter. Then let's type in a box, and we're going to give it an ID, just like usual, cap higher. We're going to make it slightly wider and deeper than the bar beneath it, so let's give it a scale of, and it needs to be slightly wider, so instead of 2.2, it's going to be 2.6. It looks pretty thin in the photo, so I'm going to give it a height of 0.05. And it also needs to be slightly deeper, so we're going to give it a depth of 0.3. We're going to raise the bar to a slightly higher position. Position equals 0 along the x-axis, a y coordinate of 1.15, and then a z coordinate of 0. type in greater than to complete your tag. This actually completes our temple, so let's now take a look and see what the temple looks like. Click on this preview on the left-hand side, and here you can see a temple. Here is now the completed temple, and we can see that it somewhat visually matches the temple on the left. If your temple doesn't look like mine, as in a piece is missing or a piece is not at the right position, double check that your code matches mine in this section for the temple. Your code may be missing a few different double quotes, make sure to include those double quotes, or it may be missing an end tag. You can also go to this URL, alvin/vr101, to see a completed version of this code. In the next step, we're going to now define a lantern. I'm going to once again open up my code in full screen. Underneath this temple, so make sure this is outside of the a-entity tag, we're going to now create a lantern. Define a lantern, a-entity. This is just to group our objects together, and we're going to identify the lantern with lantern-center. There are going to be 3 lanterns, and this lantern is going to be in the center. We're going to once again give it the ability to cast and receive shadows, and we're going to move it so that it is 0 units, so that it is in the center, and then it is also 1 unit off the ground, and then 3 units away from us. Go ahead and add your greater than sign to complete your tag. I'm going to, at this position right in between my start and end tags, hit enter twice and hit tab once so that I am inside of this lantern. Top off the lantern with a triangular prism. Here we're going to identify the primitive, which is a cone, a-cone. We can then effectively make a triangular prism by using a cone and setting the number of radial segments to be 4. So here we're going to first identify the cone with ID equals to lantern-cone. We're going to give it, segments-height equals to 1. And then we're going to give it 4 radial segments, so segments-radial equals to 4. Once again, don't forget your double quotes and don't forget your dashes. We're going to now set flat shading to true, otherwise the shadows and shading will still look round like a regular cone. So I'm going to type in flat-shading equals to true. And now we can set the radii, so the bottom radius will be 0.1. And then the height of this object will be 0.09. Don't forget that equal sign like I almost did. And then we're going to move this triangular prism up a little bit, so position equals to 0, 0.16, 0. And then we're going to rotate it so that it is facing us. I'm going to hit enter here right after this double quote. And there's our triangular prism. And to see what this looks like, I'm going to open up the preview on this right-hand side. If you haven't already, make sure to click on show and then next to the code. If you see there's a gray box right behind this next to the code like mine has, then that means your preview is already open. So click on the arrow right over here. And you can see there's a floating triangular prism right there, right in between your 2 pillars. Now we're going to add a box for the roof of the lantern underneath that triangular prism. So in your code, right after this cone, I need to tab that once more. So again, that white space, so that tab doesn't really matter. It's just to help us see how the code is organized. We just want to see visually that this cone is inside of this lantern. All right, so now that we've got this cone, let's add the box for the roof of the lantern. We're going to type in a-box, give it an ID just like before. Lantern-roof is going to be our ID. And now let's set the width, height, and depth. So we're going to type in scale equals 0.2, 0.02, 0.2. And then give it a position of one that is slightly high up. All right, so this is just a little bit raised up. All right. And so what this means is, again, the width is 0.2, the height is 0.02, and the depth is also 0. This should actually be 0.2. All right, so again, the scale is width of 0.2, height of 0.02, and depth of 0.2. So you can now see, if you move around this world, so again, click into your preview, use the arrow keys or WASD, and you can now see that there's a roof right underneath that triangular prism. Now let's add a box for the bottom of the lantern. So on this line, so this is the box that we just created. I'm going to move to the end and hit enter. And then now we're going to create another box. So a-box, ID equals to lantern bottom. Scale equals to, so a width of 0.15, a height of 0.02, and a depth of 0.15. Once again, add a greater than sign to complete your tag. And now there's the bottom of the lantern. We're now going to add a glowing looking orb, a sphere with emissive properties. We'll add an actual light to the lantern in the next lesson. Type in a-sphere, id equals to lantern-orb, radius equals to 0.03. We're going to move it up a little bit, a teensy tiny bit by 0.05. Opacity equals to 1. And emissive equals to white. So what this final property does is it makes the object look like it's glowing. So you can actually see that white orb right over there. Right, it looks like it's glowing. It doesn't seem to have any shadows cast onto it. And that's what this emissive property does. Right after that double quote, I'm going to enter just like before so that we can see how this is organized. Now again, if you're wondering how I got these really strange 0.03, 0.05, and 0 values, this is just me tuning values inside of the A-frame inspector and then copying them over. Now, I'm going to go back to the split screen, and for our final and last step, we're going to clone that lantern 2 more times. So we're not going to copy and paste, we're going to do something a little bit cleaner. So back to the code in full screen. So this was the lantern that we had just created in the previous step. We're now going to clone this lantern a few extra times. So go ahead and type in a-entity. Just like before, give it an ID of lantern. We're going to define this as a lantern that is to the left. We're going to type in a new component that we haven't seen before. This is clone is equal to lantern-center. Then the position is going to be, you can give this whatever value you'd like. I'm giving it a position of -1.25 to indicate a lantern to the left. I'm going to raise it up off the ground, and I'm going to move it away from us. Right, and there is your lantern. I'm going to do this one more time so that we have a third lantern on the right-hand side. I'm going to type in a-entity, id is equal to lantern-right, and clone is equal to lantern-center. Oops, We're going to clone the center lantern, and then I'm going to give it a position. So position equals 1.52, -2.5. Right, and now we have 3 total lanterns. I'm going to move this in a little bit so you can see the third lantern. So there are our 3 lanterns. Just to explain this clone component, we are actually using what are called CSS selectors. With CSS selectors, the # or the hashtag denotes an ID. So you specify the original lantern using an ID of lantern-center. Right, so that's what this clone component does. And we didn't cover any new concepts in this lesson, but we practiced the concepts we learned in the previous lesson. Primitives, components, and staying organized by grouping entities. We also covered 2 extra tips. One is the inspector, the A-frame inspector that we saw for tuning values. The second is the clone component. This allows us to keep our code organized instead of copying and pasting. If you'd like to access and download these slides, visit this URL. This concludes step 1. In step 2, we'll add color to your scene. Welcome to lesson 5. In this lesson, we'll continue converting a scene in nature into a virtual reality experience. In particular, we'll be adding color to our experience. Start by navigating to this URL, alvin/vr1/step2. This will open up a new project in Glitch. Like before, I suggest placing your Glitch and Skillshare windows side by side as shown here. We'll first expand our knowledge of components. Then, we'll change colors and add lighting to the scene. Let's start with components. Here is a component that we've seen before. The color component has one value, blue. This is called a single property component. It has one property, which is the value of the color. Here is a component that we haven't seen before, called material. Material is what's called a multi-property component because it supports multiple properties, like color and opacity. The property names are shown here in blue. Like before, the values are shown here in pink. Notice that to separate property names from property values, we use colons denoted in red. To separate properties from each other, we use semicolons denoted in red. We're now going to use multi-property components to change the color of the sky. Now, let's color our sky. This is our step 2 starter code. Once again, I'm going to minimize the file browser here. I'm going to start referring to objects inside of our scene by their ID, right? So the IDs that we assigned it here. Let's go ahead and navigate to the scene. Okay, so the scene is this tag right out here on line 13. Darken the sky by setting the background component's color property. Type in background equals color, and then we're going to give it a purple color. Right, so this pound sign now denotes a hex value. We're going to type in 0011A. This is just one way to define a color. Now to see what this looks like, go ahead and open your preview window, click on Show next to the code. If you've already done this, then there'll be a gray box behind next to the code, just like mine, in which case you can click on the preview right on the left. So you can see there's that dark purple in the background. Now that's it for the sky. Let's next change the color of the ground. So in our code, we're going to change the ground's color to be an indigo. The ground is at the very, very bottom. This is line 42 with an A- plane. I regretfully should have given this an ID, but it is what it is. Let's now change the ground's color to be an indigo. The current color is white, or FFF. We're going to change this to be a pound sign 841 FDE. And this is actually also a shade of purple. Right now, this looks absolutely horrendous, but we'll change this later on. That concludes the ground. Next, let's talk about some lights. Before we continue coding, I'll have to explain the 5 different types of lights you can use in A-Frame as of version 1.1.0. There's no need to memorize these. You can always Google A-Frame lights to find this list of lights again. In this lesson, I want to define each light visually so that you can get an intuition for when to use what light. Here is the scene we'll be using. The first type is an ambient light. It's an omnipresent light. Think of it like the exposure in your camera. All entities are equally affected by the ambient light. Turning down the intensity of the ambient will darken all objects, and increasing the intensity will brighten all objects. You can also add color to the ambient light to give it a scene of warm or cool taste. Back to the original settings. The second light is a directional light. Directional light you can think of like the sun. It's the light casting the box's shadow in this VR environment. Turn down the intensity of the directional light and you get less contrast in your shadows. And here's even less contrast. Notice that I could have turned up the overall exposure using ambient lights. However, no matter how intense my ambient lighting is, I won't get back the shadow contrast without directional lighting. Back to the original scene. For light number 3, we'll add hemisphere lights. To better show you its effects, I'll change these boxes to white. Here's hemisphere lighting. It basically functions like ambient lighting, except you can specify a color from below and a color from above. Here we have blue from below and white from above. Here's more hemisphere lighting, with blue from above and blue from below. This is identical to ambient lighting with blue. Back to the original scene. For light number 4, we'll add point lights. To better show you its effects, I've turned down the ambient lighting back to 0.2. Here's a point light right above the leftmost box. Notice the light shines in all directions like an uncovered light bulb. Like with directional lights, it can cast shadows. Here's the same point light shifted to the right. Back to the original scene. For light number 5, we'll add spotlights. True to its name, spotlights will cast light in one direction. As the A-Frame docs put it, this is like the bat signal. To better show you its effects, I've turned down the ambient lighting back to 0.2. Here's a spotlight shining on just part of the box, like lights you'd expect in a theater, Las Vegas water shows, or at a museum exhibit. Here's the full list of A-Frame lights available to you as of version 1.1.0. Don't worry if this list seems overwhelming. We're going to use these lights now in an example. To start, you can simply copy my lighting in each new project you make. Let's now set up your environment's lighting. Go ahead and scroll up to the very, very top of your file. Now, we'll add 3 lights to the environment. Notice that there are already 2 lights here. In my case, this is on lines 14 and 15. You can go ahead and delete both of those lights. Now I'm going to define a new light. We're going to type in A-light. We're going to set the type as directional. We're going to change the intensity, or how brightly it shines, to 0.3. Again, don't forget your double quotes, or your equal sign. Finally, we're going to give it a purplish hue. We're going to define color equals to 6909B3. This is a sort of purplish light. Not finally, we still need to add more components. Go ahead and move the light to the top right. So position equals The right means a positive X, up means a positive Y, and towards us means a positive Z. We're now going to add a multi-property component. This is the light component with the cast shadow attribute, property, and then the value is true. Right, so this means that our light can cast shadows. We're now going to add a greater than sign to close our light, and we're going to move this back here to line up with this. Oh, something's not lined up. Okay, that's the best I can do. Next, we're going to add another light. We're going to repeat this process for another directional light. We're going to type in here a-light, type equals to directional, intensity equals to 0.2, the color is white, and the position is going to be very, very close to our last light. Finally, make sure to also enable shadows that are cast. Now that we've got these two directional lights, let's go ahead and add our ambient light so that this entire scene is a little bit brighter. Right now it's a little bit too dark. For our third light, a-light, type equals to ambient. We're going to add intensity of 0.15, and then the color is going to be another purple. Oops, 6909B3. All right, and that is our scene. So it still seems a little bit dark, so if you'd like, you can turn up the intensity of any of these values and see how they work. For now, these are the lights that we need. Now, if you're confused about how to extrapolate or use these lights in other projects, to start, I always recommend adding one directional and one ambient light to any scene that you're working with, then refining or adding lights as needed. You can, in fact, just copy these lights that I have here if you'd like to. For our final step in this lesson, we'll add point lights to your lanterns as though the lanterns were glowing. These were the lights that we defined earlier. Let's go ahead and scroll down to the lantern. Right, so this is the lantern that we defined in the previous lesson. We're now going to change the color of this orb right here. So we're going to change the orb's emissive light from white to a cyan color. We're going to define here 09EDDA. Don't forget that pound sign right before your color. Notice emissive doesn't actually cast the light. Emissive just configures that object to look like it's glowing. We'll now actually have to add a light. We now add a point light at the center of the lantern, also with the same shade of cyan. That's a tongue twister. Right after our orb, let's go ahead and now type in a-light, give it an ID of lantern-light, and type is going to be a point, right? So this is our point light. Intensity is 0.2. The position is going to be slightly up above the bottom of the lantern. We're going to give it a cyan color just like before. And then we're going to ensure that this light can cast shadows. So remember, this capitalization right here for this property cast shadow is very, very important. Don't forget your double quotes. Don't forget those equal signs. Go ahead and now end that tag with a greater than sign. And you can see there are a lot of shadows being cast, one from each of these lanterns and one from both of the directional lights. And that's it. In the top left, you can click on Show, and then in a new window, and you can share the URL for this web page with anyone that you'd like to view your VR model. If you'd like, you can now load up your VR experience in your VR headset. If you have a Google Cardboard, load the URL on your phone, click the VR button in the bottom right, then put your phone in the Google Cardboard. Take a look through the lens. You may have to turn around to find your temple. The process is similar for an Oculus Quest. Access the Oculus browser and access the URL. The Oculus browser will access the website directly in VR mode. Have fun! And that concludes this lesson. In this lesson, we covered multi-property components and different types of lights in A-Frame. We then practiced both concepts by adding color and lighting to the scene. If you'd like to access and download these slides, visit this URL. This concludes step 2, adding color. In the third and final step, we'll add motion to your scene. Welcome to lesson 6. In this lesson, we'll start adding motion to your scene. Start by navigating to this URL, alvin/vr101/step 3. This will open up a new project in Glitch. Like before, I suggest placing your Glitch and Skillshare windows side by side as shown here. A-Frame itself doesn't include support for the first step of our 5 steps, a star system. However, a third-party developer created a star system that we can use. In your code, this is our step 3 starter. I've already minimized the file browser on the left-hand side, and I've opened up the preview. If you haven't already opened the preview, click on the top left show and select next to the code. On line 9, I've already added a line of code that allows you to use this third-party star system. We're going to now add this star system to the code. Right underneath your A-scene, go ahead and create a new component, A-entity. Star-system equals to a radius of 200. This radius of 200 makes some stars look bigger and others look smaller. And you're probably wondering, well, where's the motion? And that's a great question. There isn't any motion yet. We'll have to add some motion to the ground next. The ground is going to be replaced with an ocean, just like in our photo. Well, just like with the star system, A-Frame itself doesn't support an ocean object. However, one of the A-Frame developers created an ocean that we can use. Inside this code, we're going to scroll all the way down to the very, very bottom where the ground is. So this ground is just an A- plane. We're going to remove this ground. For me, this is line 71. I'm going to delete this plane. And instead of that plane, we're going to now define an ocean. I've already created code for the ocean in a file called ocean.js. If I click on the file browser on the left-hand side here, you can actually see the ocean.js. For now, we don't need to worry about the contents of that file. We're going to close this file browser once more, and we're now going to add the ocean object on the very, very bottom. We're going to now type in A-ocean, and position is equal to 0.10. Right, so this will move it up just a little bit off the ground. We're going to give it the ability to receive and cast shadows. We're going to make it fairly deep and fairly wide. We're then going to configure how quickly and how slowly it actually fluctuates. You can change these values however you see fit. I've set some arbitrary values here. I'm going to give it an amplitude of 0, amplitude variance of 0.2, speed of 1.5, and speed variance of 1. You can change these values however you'd like to see how the ocean behaves and reacts. We're now going to set its opacity to 1 so it's not see-through. And we're also going to set the density of the points in that space to 50, so there are a lot more polygons moving around to simulate the water. Now you're going to give it a color, 841 FDE, and add a greater than sign to complete your ocean tag. So now our ocean is a purple hue. We're going to add another ocean tag that is transparent so that there's a little bit more water-like behavior. So A-ocean. Position equals to, again, the same position, so it's slightly off the ground. I'm going to give it the ability to receive shadows, a depth of 50, width of 50, so the same size. We're going to now make it slightly transparent, and we're going to make this have a little bit more variance in amplitude. We're going to give it the same speed and the same speed variance. And then the density, or how many waves that you can see here, will be 50, and then the color will be the same color as before. Right, and that completes our ocean. You can see now the preview on the right hand side. Next up, we're now going to move the lanterns. So we're going to translate or change the positions of and rotate each of the lanterns. Back to the code. And here, go ahead and scroll up to where your lanterns are. So in this case, we have lantern-center here on line 40. So to animate an object, we'll use the animation component. Like with other components we've seen previously, the animation component has multiple properties. Let's create an animation now. In A-Frame, you can create multiple animations for a single object by adding 2 underscores and adding a unique identifier. In this case, we're going to click into the start tag here on line 40, right before that greater than sign. So again, right before this greater than sign, we're going to hit enter and type in animation. We're going to give it 2 underscores and then a unique identifier. In this case, we're going to call it a position animation. There are 3 different required properties for any animation. The first is you need to specify which property you want to animate. In this case, you will animate the position property. So we're going to type in property position. Make sure to add a semicolon right after that. There's a second property that we need to add, which is the starting value. In this case, the starting position will be the original position of the object, which is 0, 1, -3. So here we're going to define from 0, 1, -3, semicolon. The third required value is the ending value. In this case, the ending position is some arbitrary position. I've set -1 to -4. So here 2 is -1 to -4. Remember, spaces between these values, no commas. Make sure you add a semicolon. And there are a few extra animation properties we're going to set to ensure that your lantern keeps moving. We're going to set loop to true so that it continues to loop. This space after the colon is completely optional. You'll notice that I've been inconsistent with this, unfortunately. But this loop true will loop the animation indefinitely. If you don't set the loop to true, the animation will happen only once. Next, we're going to set the direction, or just dir, colon, to alternate. This means that the lantern animates in both directions, from point A to point B and back. If you don't set direction to alternate, the lantern will animate from point A to B, then jump back and animate from point A to point B again. Next, we're going to set the duration, short for, or dir, to 8.5 seconds. So we're going to set here 8500 because this is actually measured in milliseconds. I'm going to add a semicolon. And now that I've done that, we're done with this animation. So you'll see in the preview now that the lantern is moving, right? Or not? Yes, right here. So it disappeared for a little bit there. You can see the lantern is actually moving a little bit. But what we want to do now is make the lantern wiggle a little bit with some animation, or so with some rotation. So right after this, let's type in animation rotation is equal to, and the property will be the rotation property this time. We're going to say that it's from 5, 10, 5, and to -10, 5, -5. You can set these to be whatever you'd like. Just make sure it's small values so that it's not rotating too aggressively. Just like before, we're going to loop this animation forever. We're going to alternate directions so that it smoothly animates between 2 points, and the duration will be 2 seconds, so 2000. All right, now we've finished the rotation animation, but what you'll notice is that the lantern isn't actually wiggling. Right, it's not rotating at all. And so let's go ahead and pull up the inspector like we learned in the last lesson. Go ahead and hit Control, Option, and I. And now if you look at this lantern, go ahead and click on the lantern on the left-hand side here, the lantern dash center, and you'll see there's the animation position just like we'd expect, but there's no animation rotation. And so that should tell you that something is wrong here with the name. And in fact, if you look on the left-hand side, do you see the bug? The bug is really subtle. This is 1 underscore instead of 2 underscores, right? Like we said before, animation must be followed by 2 underscores and then the identifier. So let's go ahead and add in the second underscore here. And now the lantern is clearly wiggling, both rotating and moving. So again, make sure that you have your double underscore, make sure you have your equal sign, your semicolons, colons, and just in general, make sure that your code matches mine exactly here. All right, that's it for the lanterns. Let's go ahead and move on to the next part. We're going to now define animations for the lantern orb. It's going to pulse and grow in intensity and then shrink in intensity. Go ahead and scroll down to the orb. Right, so this will be lantern-orb right here. And we're going to change the opacity of the orb so that the orb appears to glow brightly and then more dimly alternately. Later, we'll make the light itself brighten and dim accordingly. Like before, we'll specify the property to animate the start value and the end value. Loop it infinitely and alternate directions. Here we're going to define animation __ opacity. And we're going to give it the property that we want to animate. We're going to say where it animates from, where it animates to, so this is the end value 1. We're going to loop it forever and then alternate directions for the animation. Right, make sure to have your colons and semicolons and double quotes, equal signs, double underscores, all the punctuation. Right, and now you can see that the orb is actually changing in opacity. So this one, the one in the center, and the one on the right, all of them are changing. All right, and that concludes our lantern orb. Next, we need to actually animate the light itself. So make the light brighten and dim. So let's go ahead and scroll down to the light itself. So here we want to animate the lantern's light to brighten and dim periodically. We're going to add animation and distance, intensity is equal to, and then let's name the property You want to say what it's from, right? The starting value, the end value. And then we're going to loop it forever and set the direction to alternate, just like before. Now this is the intensity of the light, so how strong the light is within its radius of impact, but we want to actually expand the light so that its distance, or the radius of impact, actually increases. So let's go ahead and add another animation. This will be animation underscore distance, and this is going to change the distance property of our light. We're going to start from 1, the default, to 2, so that it appears to affect more of a region around it, loop it forever, and alternate directions. So you can see here that only the light, or the lantern in the center, is actually animating. The other 2 lanterns on the side are not. So I'm going to go ahead and animate those other 2 lanterns as well. Feel free to follow along. You can also customize them however you'd like. To access and download these slides, visit this URL. In this lesson, we added several types of motion cues. And that concludes this virtual reality experience. We've covered the 3 steps involved for creating any virtual reality experience: primitives, color, and motion.